For our last example in this lesson, we're going to take a look at C#'s logical operators. And for the purpose of this example, what we have is a simple program that's going to display the truth tables for each of the different operators so that we can see how those operators combine conditions of true and false. Now, in C#, you actually have two different versions of the and or operators. You have what we call the conditional and, which is the double ampersand, and the Boolean logical and, which is the single ampersand. And these two operators work basically the same way. The difference between them is what we call short circuit evaluation. In the context of a double ampersand condition, a conditional and, what's going to happen is the left side will be evaluated first, and if the left side is false, the right side won't be evaluated at all, because the only way the whole condition can be true is if the left side is initially true. So as you can see here in this first chunk of code, we're combining the values false and false, false and true, true and false, and true and true. And by the way, when you display the value of a Boolean as a string, the word true or the word false will appear on the screen. So let me just go ahead and run this so we can look at the output as we go. And we can see here that for the conditional and, the only one that results in true is the one where the left side is true and the right side is true. And for each of the other three, the first two will perform short circuit evaluation, because with the left side being false, it's guaranteed that the whole expression will be false. In the third case, the left side is true, so it's still possible for the entire expression to be true, in which case the right side will be evaluated, and because it's false, we can see that the result is false in that case. Now, if you look at the combinations for the Boolean logical and operator, which is the single ampersand, you see that the results are the same. The difference between these two operators is that you are guaranteed with the Boolean logical and that both the left and the right side of each condition will be evaluated. Now, for the OR operator, we have the conditional OR, which is the double vertical pipe operator. And in this case, the entire condition will be true if either the left side is true, the right side is true, or both are true. So you can see once again that we're combining the values of false and true with the double vertical pipe, the conditional OR operator. And for 3 out of the 4 cases, the result is true. Now, in the first case, given that the left side of the condition is false, we don't know yet if the right side is false, so we have to evaluate the right side. Therefore, no short circuiting will occur in this first case. So the same is true in the second case as well. You see the right side is true, so the whole expression is true. For these last two cases, because the left side is true in each case, short circuit evaluation will occur, which is because of the fact that the entire condition is guaranteed to be true if either or both sides are true. And since the left side's already true, the entire condition is already true. The Boolean logical inclusive OR, the single vertical pipe operator, is the same as the conditional. The only difference is that you're guaranteed to have both sides of the expression evaluated. And this is important if you have a case where the right-hand side expression for the Boolean logical AND or the Boolean logical inclusive OR is going to perform some sort of side effect where it perhaps modifies other objects or variables in memory. Now, in addition to those 4 operators, we also have the exclusive OR, the Boolean logical exclusive OR operator, which will only evaluate to true if either one side or the other side of the expression is true. If both are true or both are false, then the entire expression is false. So this next chunk of code is going to produce the output that you see here. And you can see when both are false, the result is false, and when both are true, the result is also false. So in the middle 2 lines where only one side has true, then the entire expression is true. And finally, we have the logical negation operator, the exclamation point, which simply reverses the value of a condition. So not false results in true, and not true results in false. And you can see that in the truth table here for the logical negation operator that we displayed from the program.